Hello students, this is Mr. Sims. It'll be our first recorded lesson of the 2018 year. We are on page 33 and this is an extension of the work that we've been doing in our lesson objective being to use equations to solve problems. Okay, so I want to emphasize in the fact that we're going to write an equation for these. Even though some of these problems you might be able to solve without an equation. All right. But keep in mind, eventually you're going to have to use equations, so we start using them now. So we're going to do, this video is going to be examples 2, 3, and 4 on page 33, and then your work afterwards will be the exercises and the problems on the following pages. Okay. In example number 2, okay, reading through, and in this case I'll read the last sentence, but this one doesn't really have a question. Actually there is right here. Part B, if Sally designed 5 web pages last month, what was her take-home pay after her expenses? All right. So expenses are money that is paid out, or is money that is taken out of a paycheck. So eventually you'll have a job and you'll start to understand, like, this is how much money you make, but then they take a certain amount of money out. So going back to the beginning to read, to get the annotating in, Sally designed web pages for her customers as a way to make money. She charges $135.50 per web page. However, she must pay a monthly rental fee of $650 to rent her office space. So what we're going to do is we're going to write an algebraic equation, an expression, to determine her take-home pay after expenses. All right. So we're going to make a let statement, as I mentioned earlier, but we're going to let W equal the cost, or how many web pages. So a web page. Right? So what we know is that it's $135 per web page. So $135.50 times W. Right? If I have one web page, I multiply by 1. If I have 2, I multiply by 2, and so on and so forth. Okay? Now, the monthly rental fee is going to come out of the money that she makes. So that's going to be a minus $650. So this is going to be the expression that would represent her take-home pay. Right? So now, part B says, if she designed 5 web pages last month, what was her take-home pay after expenses? So the 5 is going to go in place of W. So it's $135.50 times 5 minus $650. And if you think about your normal order of operations, the normal order says that I should multiply first, then subtract. So I'll take $135.50 times 5, which I get $677.50 minus $650. She'll bring home $27.50. Probably not worth it. So bottom line is she would want to design a lot more web pages if she actually really wants to make money in a month. Right. So that one wasn't actually an equation. It was just, how do we write an expression using real-world material? And a lot of these problems are going to be something very similar to this. We're going to write an equation. Example 3. Okay, we're going to read for the gist. What? Look for the word what. The cost of each sweater. Right? And we are going to write an equation. I want to stress. And some of the problems that you will see, especially even on the state test, will say you must write an equation, which means an equation is how you get full credit. All right, I'm actually going to use a tape diagram in this particular example to give you a visual model of how this works. You don't always have to use tape diagrams, but they are very helpful. So Mrs. Hurd bought 3 pairs of jeans that cost the same amount. That's important. And 1 top that cost $15. Total of $150. Okay, so here's what a tape diagram could be used. So I'm going to take 1 and break it into 3. And I'm going to call J. We're going to let J equal jeans. So I'll have 3 boxes for the 3 pairs of jeans. Okay, 3J. Okay. I'm then going to tack on an additional box that has $15. So $15 being the top that she bought. So that $15 will get added on to the 3 pairs of jeans. Okay? And together, total. Remember, total really means add. So you're taking 3 pairs of jeans and you're taking $15. And here's what your equation looks like. And you put the 150 on at the end. So this is just a visual, and if a tape diagram is something that can help you, then by all means use it. If not, you can just go straight to the equation. All right, so now we solve this equation. All right, so we start with, remember, we always undo the addition and subtraction first. Well, we don't always do it, but in these problems we do. 150 minus 15 would be 135. Divided by 3. J equals 135 divided by 3. 45. $45 for a pair of jeans. Okay, pretty expensive. Now there is an alternate method, and it's that working backwards method where you start with the $150. And if you watch what happens here, this is working backwards. Start with $150, and this will get you partial credit. So this will get you the answer. One top that costs $15. So we're going to work backwards from it. So we're going to take off the $15 for the top, leaving me with $135. That's split between 3 pairs of jeans. So divide it by 3. And you can see that if you look here, there's the work that you did to work backwards. All right, and one more. Example number 4. Okay. Read for the gist. How many miles did Mrs. Kylie drive if the cost of renting a car was $92.40? Right. So to rent a car, ABC Company charges $75 a day plus 5 cents a mile. We want to find out how many miles. So that's what we're going to do. So we're going to let M equal the number of miles. And I do tend to like to use letters that represent the problem. So she charges $75 a day. So start with the $75 plus 5 cents a mile. So we'd write that as 0.05 M. So for every mile, it's 5 cents. That would represent multiplication. Equals $92.40. And there's your equation. Now we just solve it. And what's nice about these is there's not a lot of negatives in these word problems, so we shouldn't really be bogged down by making negative mistakes very often. All right, here's my variable, line down the equal sign. And now I have the $75 out here, so I'm going to start by undoing that. Remember, this is multiplication. We don't do multiplication until second. That's the second thing that we do. So we subtract $75. All right, and 92.40. That's $17.40. And we have 0.05 M. So after the $75 comes off the top, it's $17.40. You divide that by 0.05. And we get 348 miles. All right, so this concludes the lesson video with these examples. So your checkpoints will be the problems on the next page. So we've got pages 34 to like 37, and it's just a bunch of problems to get used to. So for recorded lessons, this is Mr. Sims signing off.